We're going to look at a very beginner approach to naming organic compounds. The first thing you want to do is look at the number of carbons. So all organic compounds are based on carbon. So the number of carbon is the first part of its name. The second thing you want to look at is bonds between the carbon. So if there is a single, a double, or a triple, that will affect its name. And the last thing you want to look for is to see if there's any functional groups. Now I'm going to break down each one of these a little bit more. So let's start with the number of carbons. We'll start using this example. The first part of its name is going to be how many carbons it has. So you just want to look up how many carbons are in this carbon chain, and there are 3. So if we have 3 carbons, then we can start this name using the following chart. If it has just 1 carbon, then it has the prefix meth. If it has 2, it's eth. If it has 3, it's prop. If it has 3, it's bute. I know it looks like but it's bute. And from here on out, if you're familiar with inorganic naming, these will sound really familiar. So 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dex. So these are all the same as the inorganic naming, just minus the a at the end. So instead of penta, it's pent. Okay, because our example has 3 carbons, its name will start with prop. The next step is to determine the type of bonds between the carbons. Now it's really important that you're just looking between the carbon. In this one, we have 1 single bond and we have 1 double bond. You could have single bonds, double bond, triple bond. You're looking for the bond with the highest order. So double is a higher order bond than a single bond, and triple is a higher order bond than double bond. So in this case, this double bond is going to be the one that dictates the naming. If they're all single bonds between the carbon, then the next part of the name is an. If there is a double bond, then instead of an, we would write een. And if there is a triple bond, instead of een, we would write ein. All that's changing is a really important vowel. This tells you what the highest order bond is. So in this case, because we have that double bond, this is propene. And then you look for any functional groups. Now there are a ton of functional groups, but we're only going to look at 2 in this video. So if you have a functional group that looks like this is what we call a ketone. If you have a ketone, the ending of your molecule's name is -one. If you have something that looks like this, with a carbon single bonded to an oxygen bonded to a hydrogen, this is called an alcohol. If your compound is an alcohol, has this functional group in it, then it ends in -all. So we're just going to look at these 2 functional groups in this video, but there are a ton of other ones. So let's go back to our example compound and see if we see any. Most functional groups contain some other element besides carbon and hydrogen. If you only have carbon and hydrogen, you don't have functional groups. So then, if that's the case, you don't have an ending like -one or -all to put on the end of it. You'll just end its name with an E if there's no functional group. So the name of this molecule will be propene. Let's try another example. Remember, the first step is to look at the number of carbons. How many carbons are there here? So if we look at this chain of carbons, there are 5 carbons in a row. So our number of carbons is 5. Remember that that prefix then is pent. The second thing we're going to look at is the bonds between carbons. In this case, all of these carbons are single bonded to each other because there's only 1 dash shown between each carbon. Because they're all single, we write an. If it had been double, we would write een. If it had been triple, we would write ein. And the last thing we do is we look for functional groups. In this case, we're just looking for those 2 functional groups. Do we have an alcohol or a ketone? Let's look for oxygen if you're doing the simple version. We have an oxygen right here, which is a dead giveaway that we have a functional group. So we have to just determine, is it a ketone or an alcohol? Now a ketone, remember, is double bonded oxygen to carbon, and then that carbon is also bonded to 2 other carbons. And an alcohol has a single bond to the oxygen, and that's also bonded to a hydrogen. So if we look at this one, this is a carbon double bonded to an oxygen, and that same carbon bonded to two other carbons, which is a ketone. And so if it's a ketone, then our ending is -one. So the name of this compound is pentanone. All right, I'm going to give you one more example. I want you to pause the video and see if you can figure out the name before we go over it. The first thing we're doing is looking at the number of carbons. There are just 2, so that gives us the prefix F. Okay, the second thing we're looking at is the bonds. We see this bond right here is the only carbon-carbon bond, and that is a single bond. So this gets an and then the last thing we're looking for is functional groups. Find our oxygen here, and we see that it's a carbon single bonded to an oxygen, single bonded to a hydrogen, and that is an alcohol. Okay, so if we have an alcohol, then the ending is -ol. So the name of this compound will be ethanol. So now if you look at a shampoo bottle or a lot of different substances that you have around your house, you'll see names with that meth prefix, that -ene and that -an and that -ine, -ols and -ons. So you'll start to be familiar with some of the places that you can find organic compounds in things that you own. Now you'll also notice with those names that they're a lot more complex as you would go on learning organic nomenclature. All of that would start to make sense, but this is a great place to start.